Okay, 3.5, dividing polynomials. Okay, so did you guys learn long division? You learned it in elementary school? Yes, some of you guys? Anyone not learned it before? Haven't learned it before? Don't remember? Okay. So we're gonna go through the steps of long division. A lot of times it's not being taught anymore because of calculators. People don't need it, but I still use it on a daily basis. Not daily, but I definitely use long division. But now we have calculators on our phones, so it's so easy just to access the calculator function. When I was, I don't know if I told you guys, I taught in Australia for a year. I did my teacher college there, so I lived there for a year and I taught there. And their high school starts at grade 8. So it goes grade 8 to grade 12. And when I was teaching the grade 8 class and I was going through long division, it was like, and blank faces. I'm like, haven't learned this? And they said, no, we don't learn it at all. It was because of calculators. But I think it's good to know, or to at least have. Okay, so I'm going to show you long division to divide polynomials, and I'm going to show you another method, which is called synthetic division. Most people will like synthetic better. Okay, so long division, takes a little bit longer steps, and you have to deal with letters and stuff. Or synthetics, you just deal with the numbers. So I'm going to show you both of them today. Okay, so let's go through some terminology here. We're dividing. So we have 3 numbers there. Okay, so anyone know what any of these numbers are called? You should know the final one. Most people know that one. Any idea what those 3 numbers are called? There are 3 different names. Anyone? Valentina?
The final one's a quotient.
Good, the final one is the quotient. Okay, so we have the quotient here. We have the quotient, good. Last 2. They both start with D's. Maya?
Is one the divisor?
Divisor, good. So 4 is the divisor. Divisor. The last one that most people don't get is the dividend. And everyone knows the last one. Which one am I missing here? If I were to enter this and there's a number at the bottom, what's that one called? Sorry? The remainder, right? So everyone knows the remainder for some reason. Okay, so let's go through this. Let's say we're actually dividing. Okay, so let's say we're dividing these. For those who can remember, or maybe forget, so let's say I didn't know it was 21. Okay, I apologize in advance if I do this. It's very, very common that I'll make it a square root sign, but it's not supposed to be. It's just a line like that. Anyone learn it this way before? Everyone learn it this way, like this? I think it looks like that. Well, a lot of Eastern Europeans do a method something like this, and people from South America. I've seen that before. Okay, so how do we divide? What do we do first? So 85 divided by 4. What would you guys do? You guys all learned this before. Too quiet today. Okay, so we look at the first number, right? So we look see how many times 4 goes into 8. Okay, so how many times does 4 go into 8?
2.
Twice. Okay, so 2 times. Okay, so we go 4. 8 divided by 4 is 2. Okay? So now we're going to follow these steps because it's important that you know the steps because that's what's going to happen when we get to polynomials. So we take the 2, multiply it to 4. Okay, so 2 by 4 is 8. Okay, then we put our line. And what do we do with the operation with the 8? what do we do?
Subtract.
We do, Mike?
Subtract.
Subtract. Okay, we subtract. So we multiply, and now we're gonna subtract the numbers. So we have 8 divided, 8 subtract 8 is 0. Okay, so that's, this cancels out. You don't have to put the 0. Let's put it for now. Okay, so we multiplied, then we subtracted. Now what? Now what?
You bring down.
Michelangelo?
Bring down the 5.
Bring down the 5. Okay, so now we're finished with the first number. Now we can go to the next one, and we bring down the 5. Bring down the 5. Good. So we have a 5 here. I'm just going to take away the 0. We don't need it. And now we do the process all over again. So how many times is 4 going to 5?
1.
It goes in once, so we put 1 here. So we have 1. Okay, so then 1 times 4 is 4. Do the multiplication, and we do the subtraction. So we get an answer of 1. Okay, we're not going to go into decimals here. I'm just going to leave it as it is. We don't go into any decimals or polynomials. There's x's, so there's no decimals. Okay. So lastly, so we have 1, and we stop there because there aren't any numbers to bring down. Okay. So this last number we said was called the remainder. So we're going to find out the number. How many times the number goes into the number we're looking at? So we multiply, subtract, carry down. Multiply, subtract, carry down. And we're going to follow that process over and over again. Multiply, subtract, carry down. All right, just going to raise this up. Okay, so here, so the reason why we divide polynomials, what happens is we know a lot of factoring. You guys know a lot of factoring. You know how to do simple trinomial factoring, complex. You guys have done difference of squares. 3.7 is sum and difference of cubes. You know how to do greatest common factor. So this division is actually another form of factoring. Because remember, factoring, you're always dividing. So when you factor something out of an equation, or sorry, an expression, when you factor out, you divide. Okay? So now we're getting to larger and larger polynomials, so degrees of 3, degrees of 4, degrees of 5. That is very difficult to factor, okay, with any method. So we divide using long division or synthetic to factor the polynomial. Okay, so we're dividing now to factor. So that's what it's telling you here, to go from standard form to factor form. Okay, determine the quotient. And then it says, is the divisor a factor? So determine the quotient means get the answer. Let's divide it and let's get an answer. Okay, and then it says, is it a factor? It's only a factor if there's no remainder. Okay? Only a factor if the remainder is 0. Or there isn't a remainder, however you want to write it. Okay? It's the only way it's a factor. If there is a remainder, it is not a factor. Okay, so we're going to do the first one. I'm going to rewrite it. So I have x minus 4. Sorry, it's x cubed minus 2x. Oh, wait. Okay, there is one key component or a trick or something you have to identify with every time you divide. Okay, something has to occur. Has to, or else it won't work. You need to have your variables. Your variables have to be decreasing in exponents. Okay, so what's my highest exponent here? 3. So I have x to the power of 3. Then I have to have an x to the power 2, an x to the power 1, and then a number. Okay, so I have to have all of them. Okay, which one am I missing here? I'm missing
2.
the x squared, right? So I'm missing the power of 2. So we're gonna insert the x to the power of 2. Okay, the way we do it is we add a 0 x squared. Okay, so you must have the exponents decreasing from whatever the highest one, so in this case 3, we need 3, 2, 1, and then 0. 0 is just a number. Okay, so 3, 2, 1, no exponent.
Good morning, Robert F. Hall. Today